My name is Hammad Majeed. I am from Department Physics and today's my topic for presentation is quark. What are quarks? A quark is a type of elementary particle and a fundamental constituent of matter. Quarks combine to form composite particles called hadrons, the most stable of which are protons and neutrons, the components of atomic nuclei. All commonly observable matter is composed of up quarks, down quarks, and electrons. This is basically the definition, and in the end, we discuss the types. Actually, it has six types: up, down, strange, bottom, top. These are the six types of quarks. Quark is a type of elementary particle and a fundamental constituent of matter. What is matter? Matter is anything that has mass and occupies space. Quarks combine to form composite metallic particles like hadrons. And as you already know that subatomic particles are electrons, protons, and neutrons. But there are also some composite particles like hadrons, leptons, muons, neutrino, antineutrino, positron. Now we'll discuss about who is the inventor of quarks. In 1964, two physicists independently proposed the existence of subatomic particles called quarks. Physicists Murray Gell-Mann and George Weld were working independently on the theory for strong interaction symmetry in particle physics. This is actually the discovery or invention of quarks. Actually, quarks were mostly discussed in physics, and because it was also discovered from the particle physics, were two scientists working independently for on a theory for strong interaction symmetry in particle physics. So it is mostly related to physics. Then we'll discuss the properties. Quarks have many properties including mass, electric charge, and color. Their mass tells you something about how much matter they are made of, or how heavy they would be if you could weigh them. They can have positive or negative electric charge. Downstream in bottom quarks have a negative 1/3 charge. The properties in these properties we discuss the mass, electric charge, and color. Quarks also have color and they also have flavors. And mass, electric charge. Three types of quarks have positive charge and three have negative 1/3 charge. Because six types as we already discussed: mass, electric charge, and color. Color that they are flavored. They come in many flavors. Electric charge means positive and negative charges, and mass matlab means they are made of or how heavy they would be. These are the three properties of quarks. Mass, atomic mass, atomic weight. These two things are also related to mass. Then we discuss the shape. As far as we can tell, quarks are point particles like electrons. They have no size and therefore no shape or any other kind of structure. As far as we can tell, quarks are point particles like electrons. They have no size and therefore no shape or any other kind of structure. Actually, quarks are shapeless. They have no shape, no size like electrons. Electrons have no shape, but means they same in many respects. Like electrons, they have no size, no shape. Now look at this diagram. This is that electrons that have minus charge interact with a positive charge proton. When two charges are opposite, then they attract each other. And when two charges are positive, they repel each other. Now look at this hydrogen atom, एक इलेक्ट्रॉन एंड वन प्रोटॉन. एक जो इलेक्ट्रॉन है वो सर्कल में मैंने शो किया हुआ है. And then proton, look at the proton combine to form quarks. There are some strange facts about quarks. Teensy particles. Quarks are particles that are not only hard to see but pretty much impossible to measure. These teensy tiny particles are the basic of subatomic particles called hadrons. With every discovery in this field of particle physics in the past 50 years, however, more questions rise about how quarks influence the universe's growth and ultimate fate. Here are 7 strange facts about quarks. Teensy particles. Now, what are the teensy particles? Are particles that are not only hard to see but pretty much impossible to measure. Like like stone, quarks are not only hard to see but impossible to measure. Impossible to measure their weight and something. They are the basis of subatomic particles called hadrons. We already discussed in properties our use subatomic particles like hadrons with every discovery. And it is mostly related to particle physics because it was discovered in particle physics. More questions are about how quarks influence the universe's growth and ultimate fate. Then we look at the emerged just after Big Bang theory. The first quarks appeared about 10 raised to power minus 12 seconds after the universe was formed in the same era where the weak forces, which today is the basis of some radioactivity separated from electromagnetic force, the antiparticles of quarks appeared around. First appeared First quark appeared about 10 raised to the power minus 12 seconds after the universe was formed. It means that they formed after when the universe formed in the same area where the weak forces used to raise the basis of radioactivity. Radioactive elements separated from the electromagnetic forces which are electric field and also have magnetic field. Look towards this. The emerged just after Big Bang. You looked at in the first afterglow life pattern 400,000 years, inflation, quantum fluctuations first start about 400 million years, dark ages, development of galaxies, planets. Now this is the diagram after when the quarks were discovered after some time after universe. Development of galaxies, planets, dark energy accelerated expansion, and WMA. Third point is discovered in an atom smasher. A mystery arose in 1960s when researchers using the Stanford Linear Accelerator Center found that the electrons were scattering from each other more widely than calculations suggested. More research found that there were at least 3 locations where electrons scattered more than expected within the nucleon or heart of these atoms, meaning something was casing that scattering. This was the basis for our understanding of quarks today. Smashing its center, one center found that electrons were scattering from each other more widely than calculations suggest. First of all, some calculations are made, but when they scattered, the electrons are scattering more than the calculations suggested. So they found that there was some particle that cases the scattering, and that particle was the quarks. As we already discussed that quarks are the particles that are not hard to see but impossible to measure. Second, fourth point are common flavors. As we discover in physical properties, mass, electric charge, and color, they are the common flavors. Physicists refer to different types of quarks as flavors: up, down, strange, charge, bottom, and top. The biggest differentiation between the flavors is their mass, but some also differ by charge and by spin. These are the 6 flavors: up, down, strange, charm, bottom, and top. In these, 3 have positive charge and 3 have negative charge. The biggest differentiation between the flavors is their mass. Mass means they differ by the weight, but some also differ by charge and by spin. Spin, opposite spin. Some have positive spin, some have negative spin, and charge. Some have positive charge, some have negative charge. Common flavors, you look at 6 types: strange, up, down, bottom, top. They come in different flavors. Fifth point is may set the universe's fate. Boltzmann's brain could see cell-aware entities come out of random collection of atoms, while it is not a part of standard model. The theory framed as paradox proves that it would be more likely to see organized groups or atoms as the random ones observed in universe. Universe's fate. Universe's fate actually is the strange fact. Strange fact about quarks. What is the fate? The fate of universe is determined by its density. The evidence to date, based on the measurements of the rate of expansion on the mass density, favors a universe that will continue to expand indefinitely, resulting in big freeze scenario below. Now, a question is raised: does the universe have a fate? Everything in the universe exerts a gravitational pull on everything else, and this slows down the universal expansion. The ultimate fate of the universe depends on the amount of mass contained within it, that is the mean density of universe. In this, the Boltzmann brain could see cellular entities come out of random collections. So this is the miss at the universe's fate. Then teach us about matter. Matter, what is matter? Matter is anything that has mass and occupies space. A subject or situation under consideration, particles and antiparticles should destroy each other. One would think the universe should just have photons and other elementary particles, yet antiphotons and antiparticles still exist, leading to mystery of why the universe is made mostly of matter and not matter. Teach us about matter. Matter, first thing that on one university just have photons like light particles, antiparticles and antiphotons are also exist. Now the question is arise why the universe is made mostly of matter. The universe is thought to be consist of three types of substances: normal matter, and dark energy. Normal matter consists of atoms that make up stars, planets, human beings, and every other visible object in the universe. Universe is actually composed of dark energy, dark matter, and ordinary matter. Other contents are electromagnetic radiation, the total mass of energy. So question is asked why the universe is made mostly of matter? Because universe is thought to be consist of three types of substances: normal, dark region, and dark matter. Teach us about matter. Tricks to measure. This is also the one strange fact about the universe. Quarks cannot be measured because the energy required produces an antimatter equivalent called an antiquark before they can be observed separately, among other reasons. According to a primer from Georgia State University, the mass of quarks is best determined by techniques such as using a supercomputer to stimulate interaction between quarks and gluons, with gluons being the particles that glue quarks together. Tricks to measure. As we already discussed, that quark is not only hard to see but impossible to measure. So there are some tricks to measure quarks. If you want to measure quarks, cannot be measured because the energy required produces an antimatter, antiquark. Because if one is positive, another is negative. In the same way, one is positive, another is antiquark. Before they can be observed separately, among other reasons. According to a primer from George State University. George State University. The mass of quark is best determined by techniques such as supercomputer and to stimulate the interactions. Now a question arises: what is primer? In biology, primer is the short single-stranded DNA sequence. The mass of quark is best determined by techniques such as using a supercomputer. Supercomputer that made up a trillion of calculations per second to stimulate the interaction between quarks and gluons. Gluons like which glue the quarks together. So it is best determined by using supercomputers. Supercomputers are the most powerful computer, and it is using human genome, weather forecast, and the supercomputer can make trillion of calculations per second. Tricky to measure देखिए. Look. Now, another question is: do quarks have color? Do quarks have color? Quarks are said to come in three colors: red, blue, and green. The opposites of these imaginary colors, minus red, minus blue, and minus green, as ascribed to antiquarks. Quarks are positive and antiquarks are negative. Three colors. It is mainly it is consist of mainly three colors: red, blue, and green. And the opposites are minus red, minus blue, and minus green. Next question is: are quarks stars real? This is the question. Are quarks stars? NASA announces evidence of stronger stars now. What is NASA? NASA brings you the latest news, images, and videos from American Space Agency, future in space exploration, scientific discovery. NASA stands for National Aeronautics and Space Administration. It mainly tells us about news about stars, satellites, oddball, born in supernova's blast. Oddball is the name of star. Oddball is simply, it is also an app to turn off the blink, simply disconnect it from there. We will see the LED blinking and automatically turn off 30 seconds. Oddball born in supernova's blast 3C58 seems too cool to be made of normal matter. Astronomers may have discovered two of the strangest objects in the universe, two stars that appear to be composed of dense group of subatomic particles like quarks. Are quarks stars real? NASA give us information about satellite. It announces evidence of stronger stars, oddball born in supernova's blast, and other 3C58. This is so cool. And oddball is because it's born in supernova's blast, so it is explosive and dangerous, also dangerous. Are quarks star real? Look at this diagram. These are the two stars which now what is the summary of quarks? Quarks is an elementary particle and it has three types. Now we look at the summary. What are quarks? Quarks are subnuclear particles which form protons and neutrons, among many other things. Quarks come in six types, whose name of up, down, change, down, top, and bottom. Up and down are the only types that exist in ordinary matter. They have no size, no shape. They are hard to measure. Then we discuss the properties like mass, electric charge, and color. Inventor, two scientists independently in theory in particle physics. Now we look at the properties. Now we discuss the properties like mass, electric charge, and colors. Now shape, they have no shape. They have no shape. They have no size like electrons. Then strange facts, strange particles, tricky to measure, tell us about matter, emerged just after Big Bang. May at the universe is discovered in atoms, measure common flavors. May at the universe is fate, we tell about matter, tricks to measure, because, as we discussed, they are hard and impossible to measure because energy required produces an antimatter like antiquark. So it is difficult to measure, but antiquarks are opposite charges. They are the positive. They are six types, and they have three colors: green, red, and blue. And the antiquarks are opposite colors. One is red, minus blue, minus green. Actually, they have plus 1 by 3 and minus 1 by 3. We have two charges. And then we discuss, are quarks star real? NASA noticed evidence of strongest stars now as old ball in supernova's ball and precipitations to be pulled to made of normal matter. And this is all about quarks. And thank you so much.